Hi, this is King of Review. Here we have a sequence 1, 2, 4, 7, 11, and so on, and we need to find a way to express that as one of these four possible answer choices. We need to find a way to express the nth term of this sequence. Well, let's see if we can find a pattern in these numbers. I usually start by looking at how much these numbers are going up each time. From 1 to 2, we add 1. From 2 to 4, we add 2. From 4 to 7, we add 3. And from 7 to 11, we add 4. Now this is clearly a pattern. We're adding one more for each term in the sequence. Let's think about this pattern itself. The pattern 1, 2, 3, 4, and so on. The pattern of numbers that we are adding. This is a very straightforward sequence. The first term is 1, the second term is 2, the third term is 3. So essentially, every single term matches the term number that it's on. And if we want to know the nth term, we will have to take the number 1 and add up all these other numbers. 1, 2, 3, 4, 1 plus 2 plus 3 plus 4 plus all the way up until n minus 1. If we want the nth term, we have to add up all these numbers until n minus 1. The reason for n minus 1 is this. When we want the second term, we only had to add one number to our starting number. When we wanted the third term, we had to add two numbers, 1 and 2. When we wanted the fourth term, we had to add three numbers, 1 and 2 and 3, to our starting number. So whatever term you want, if you want the fifth term, you're going to have to add 5 minus 1, or 4 numbers together onto the initial term 1. So whatever term n we want, we're going to use our starting number 1 and add up n minus 1 numbers after that. One fewer number to add than there are terms. So this is another way to express the nth term, but it still doesn't look like any of our possible formulas in our answer choices. But there's a very nice rule that says if we want to add up this sequence that we have here, 1 plus 2 plus 3 plus 4, and so on, and let's say we stop at some number m. There's a mathematical rule that says the sum of all the whole numbers from 1 to m is m times m plus 1 over 2. But now let's say we have a different sequence. Let's say we have this sequence 1, 2, 3, 4 until n minus 1, the sequence we're adding in our nth term. If we apply this rule, substituting in n minus 1, we get n minus 1 times n over 2. And that's starting to look a lot more like some of these patterns. So let's see what we know now. We know an is going to be our starting term, 1, plus the sum of this sequence, which we figured out is n minus 1 times n over 2. Let's do a bit of algebra here. N minus 1 times n is n squared minus n over 2. If I want to combine these two terms together, I have to change 1 into a common denominator. 1 is the same thing as 2 over 2. Now both fractions have a denominator of 2, so I can add the numerators together, and I get n squared minus n plus 2 over 2, which looks exactly like, which one is it? The last one, choice D. Now just to make sure, let's make sure this works for the first term as well, because so far all we've considered are all the terms after the first term. Let's check it out. A1, if we plug in 1 for n, we get 1 minus 1 plus 2 over 2, which is 2 over 2, which is 1. And that's exactly what we should have gotten for the first term. So this expression definitely works out for all the terms in our sequence. Thanks for watching.